Let me give you guys a quick example and then I will give you some practice. So given that y here is directly proportional to x, find out the value of y when x is 28 and also find out the value of x when y is 99. So whenever you see this directly proportional thing, when you're told that y is directly proportional to x, inside your mind visualize it like this. It Well, whenever you're given this directly proportional thing, it basically means it's this kind of a relationship where when you times this by 2, then you also times this by 2. When you times this by 3, then you also times this by 3. When you half this, you also half this. So whenever you see this directly proportional thing, it's telling you the relationship between y and x here. It's that kind of a relationship where you double this, you also double this. When you half this, you also half this. So when you see this, it's this kind of a relationship. Now, when you have this kind of a relationship here, you can actually plot the two relationships here. So here when x is 2, y is 3. So if you try and plot this, when x is 2, y is 3. So that would be here, okay. And the other one is when x is 4, y is 6. So when x is 4, y is 6. So that would be here, okay. When x is 6, y is 9. So hang on, when x is 6 here, y is 9. So here, and hang on, here. Okay, so as it turns out that this here it actually it actually forms a straight line here. So whenever you have this kind of relationship where when you double this, you double this. When you half this, you half this. Whenever you have that kind of relationship, it always forms a straight line here when you plot the points. Okay, so when you're told that y when you're told that y is directly proportional to x, it's going to form a straight line like this, always going through the origin. So when you have a straight line, you can visualize this y equals mx plus c. That's a formula for a straight line. Now c is the intercept. It always goes through the origin. So we can pretty much take c as 0. Okay. So whenever you're told that y is directly proportional to x, you can actually move to this to this line here, this straight line here. Well, whenever you're given this, you can actually write this y equals k x here. This k is very similar to the m here. So m is the gradient. So in this case, k is also the gradient here. Some books use k. So I guess we have to use k then. So here the k here would be the gradient. Well, the gradient here is really the gradient would be the height divided by the across here. So the height is 3, the across is 2. So the gradient is 3 over 2. So that k there, this k here is actually 3 over 2. But let's just pretend we didn't know that. Let's just say that we've been given this here. We're told that y is directly proportional to x. So well, when you're told that y is directly proportional to x, you know it's going to be a straight line. Okay, the relationship between x and y will be a straight line. So, well, it's a straight line, so you're going to have something like this: y equals kx. This k here is the gradient. But let's say you didn't know the gradient. So let's put this into the x here, okay, and then put the y here into this y here. So it's a matter of 3 equals, because you're putting this 3 into the y here. Remember, we're trying to find out k, and then we're going to put the 2 into this x here. Okay, so it will be k times 2 here, and remember, number always before letter. So in effect, it becomes 3 equals 2k. Now, if you want to know k, then divide both sides by 2. So 3 over 2. So our k here is 3 over 2. Okay, so hang on. So when you're told that y is directly proportional to x, and you're given these data points here, you in effect have a graph of y equals 3 over 2x. Okay, so from this thing here, remember we plotted our graph, and it's a straight line, and that straight line is y equals 3 over 2x. Okay, so now if you look at this here, if you put this x into here, into this x here, it will be 4 into this x. So times this here will be 12. 12 divided by 2, it will be 6. And look, this 6 here matches with this. Okay, so well, once you've got the relationship y equals 3 over 2x, you can actually find out this now. Okay, so when x is 28, then you put this 28 into this x here. So it will be 3 times 28 divided by 2. Okay, so hang on, 28 times 3 equals 24. Carry the 2, so 84, and then 84 divided by this 2 here will be 42. So this thing here will be 42. Okay, and what if you want to know x here when y is 99, use this equation here. So put this 99 into the y here and work backwards to find out x. So it will be 99 equals 3 over 2x. So it's a matter of finding out x. So at the moment it's x times a fraction, so it gets multiplied to the top. I'm just going to visualize it like this. Equals 99. So now times 2 to both sides. So that will be this times 2 would be 198 here. This one will be this here, and divide both sides by 3. So hang on, where's my calculator? What is it? 198 divided by 3 equals 66. 66. Okay, so up here, this here would be 66. Okay, in the next in the next video, I will give you some practice. Okay.